Hello everyone, today we'll look at how to add constraints to AutoCAD drawings. So up to this point we have studied actually the non-parametric features in AutoCAD. Now today I'm going to look at parametric features. So I'm going to basically look at this area now. I'm going to give some intelligence to the AutoCAD software. For an example, if you do all these tools are behaving like non-parametric tools. So if you just draw a line, and if you try to put a dimension, say line dimension, now this value is 8.37. If I try double click and try to override this dimension, I'm going to override this now. Say if I say 10 for an example, this line length will not change. So this is like there is no connection between the dimension and the line. So this is non-parametric behavior. So if you double click and again say have letter A, software will not give you any error. So this is non-parametric behavior in AutoCAD. So this is not really good in terms of editing, and people can see it in your drawings. So it's difficult to edit your drawings in non-parametric mode. Now this parametric mode is easy to operate, but lot of people don't use this. But if you want, you can use this and do your drawings, or else you can use a combination of parametric and non-parametric techniques to do your design. So if you dimension using parametric methods, I'll do a dimensioning, a line. You see there are locks everywhere, meaning that there's a connection between the actual line and the dimension. So specify first point curve or object. So you can the first point like this, second point like this, and it shows you the same dimension, but it comes as d1. So d1 is the variable here, parameter. So if I just double click and try to change say d1 into 10, you see this line length is now changed as 10. This is unchanged 8.3. So you see there is no connection between this dimension and this other dimension. But if you want, you can drag it and change it later, but it's done manually. So this is not parametric. So this is the parametric dimension. So we are going to look at this area now. Before moving on to this dimensioning schemes, we will look at how to use these parametric methods to do a design. So you don't need to draw accurately from the beginning like previous cases. So we have these geometric constraints as well as dimensional constraints. So we will look at what are these geometrical constraints first. So we have these horizontal, vertical, coincident, likewise up to smooth constraints. So this is if you have studied SolidWorks. SolidWorks has all these constraints, geometric constraints. So that's why people like SolidWorks more than AutoCAD. So SolidWorks is easy to handle in terms of sketching. So AutoCAD we have to do it very accurately, but if you know these techniques, you don't need to do accurate drawings. We will look at one by one these techniques quickly. Now if you have a, say for an example, if you want to draw say I'll take an example and explain you these concepts that may be easy for you. We will take an example. This example I'm trying to use parametric methods and draw. So the idea is you don't need to draw accurately. We don't use this offset into those things. We just use like rough sketches and freehand sketching. So I'm going to draw some freehand sketches. So this is my drawing. So I'll just start somewhere here. So I'll just draw some lines without paying attention to the dimensions as well as the horizontal vertical conditions. So I'll just draw something. We will later adjust this. and I'll show you how to adjust this. Now I just drew some sketch. So now we are going to use these parametric constraints, geometrical constraints. So the first constraint I'm going to use is easiest one is the vertical one. So I'll try to use this vertical constraint. So when I use the vertical constraint, you will see this is now vertically adjusted, but uh, this joint was broken. So that means I have to have some coincident geometrical relation between these two lines. So when you start a drawing, it's best to apply these coincident symbols everywhere and start this. So this is coincident, we can repeat this, then it will not break. So here it was broken, so I'll just apply coincident again for this point and this point. Then we can repeat the coincident, this point and this point. Then you see some dot blue color gripper shapes coming, this one and this one. So this won't break now. So you have to have these coincidence everywhere in order to have a accurate drawing. So coincident, this is already broken, we will apply this, and now every joint is okay. Now I'll apply the horizontal conditions. So this is horizontal, you see now symbols appears. So if you want to just delete it, right click and delete, or else you can hide the things. So better you make it visible. Later if you want, you can hide it. So now this is horizontal, and this is vertical again, this is horizontal, and these two lines should be collinear. So there is a button called collinear, so this should be collinear to this. So this is the parent, this is the child. So you see child adjusted according to the parent. So and if you want this to be adjusted according to this, so this is the parent, so we'll get the collinearity. So you see it's adjusted. If you select the other way, so this is the parent, this is the child, so the child always moves. So remember, normally all these constraints, parent won't move, child will move, but in this smooth condition, parent will move. So I'll show you what is meant by smooth later. So now we have given horizontal and vertical conditions and the collinear, and we have perpendicular relations. So in this example I don't need to give actually perpendicular relation, it's already perpendicular because this is horizontal and vertical. Now when you try to give more than required, this will pop up a message saying it's going to over constrain the geometry. That means you are going to define more conditions. So this perpendicularity is not needed here because this is vertical, this is horizontal, so I don't need to give perpendicularity. Yeah, press OK to reselect. So you cannot apply that condition here because already it's perpendicular. So here also I don't need to apply perpendicular, I don't need to apply perpendicular, but here we can apply the perpendicularity, or else you can make it vertical. So I'll just apply perpendicularity and show you. So this the parent, there's a child, you see it's adjusted. Now I didn't worry about the dimensions, I just try to get the shape first by applying the geometrical conditions. Now we have this equal relations are now equal, so this should be equal to this one, as well as this should be equal to this one. And now it's not needed because others are equal, so I don't need to give this. Better I check this one, this should be equal to this one. Now it's almost okay, so I've used coincident, collinear. I didn't use concentric. What is meant by concentric? We will come back to this example in a while. I'll save this drawing for the time being in case if power goes off. So we will look at what is meant by the others. concentric. So when you want to draw some circles, early days we have to worry about the circle position, center points, everything. Really a headache. Now here I didn't worried about that. I just drew some circles, and if they share the same center, you just use the concentric relation. Automatically the child will move to the correct location. So this is concentric. And there's another button called fix. So if you don't need this line to change, now this can be changed. You can see you can change the length. So if you fix this line, that means you are going to pin it to the screen. So you see a paddle lock coming appears, and if I try to do some changes, you can see I cannot move it. You can change the length of this line, but you cannot change the location. So it's actually pinned to the screen, so you can always delete the condition. Now you can move. So fixing is sometimes important in order to avoid unnecessary editing. Then we have this parallel relation. So if an example, if I draw something like this, and if I have another line like this, normally we may try to use the offset tools and try to get the parallelism, but you don't need that. You can just apply the parallelism geometrical conditions like this and quickly adjust your drawing. Then we have perpendicular I discuss, horizontal vertical I discuss, tangent relation. So example, we may have a line like circle like this, and a line goes like this. Early days when I want to apply the tangency, you have to be careful. You have to use these object snaps and do some operations, but it's not required now. You can just draw a rough sketch and apply this tangent relation. Circle is the parent, this is the child. If you select the other way around, this is the parent, this is the child, circle will move. So you see how it works. If you fix this circle, now the circle is fixed. That means what is the meaning of that? It can change the diameter, but it can't move. Now if you try to apply the tangency, this is the parent should not move, child should move. So child radius only will move. Earlier the center moved. So I hope you can rewind the drawing and see the video and see what happened earlier also. Now we have this symmetric conditions. So if you want, you can draw a center line and make the drawing symmetric. So now center line is not drawn, so I'll just draw a normal line. Say this is my center line. So this should be perpendicular. So sorry, vertical. So this is vertical. Now this should be fixed. And this should other part should be symmetrical around this line. So I can use the symmetric condition, symmetric. But it says select the first object. This is the first object. Select the second object. Select the symmetrical line. So you see it's adjusted now. So the idea is now it's very simple. You can change this location. See the drawing is nicely now adjusting around the center line. So center line, you can use the center line, actual center line from the layers. I just use this normal line tool here. Now equal symbols also I have discussed. What is meant by smooth? So smooth is say I'll take an example. I'll use the splines. Now you have something like this. Enter. We'll draw another spline. I want to connect these two splines smoothly. There was a tool called blend under fillets. We have discussed this. When I select this is the output, so it will draw an additional line or a spline. But if you don't need that to happen, and if you want just to connect these two smooth this is the parent, this is the child. You can see only in this case the parent moves and made a smooth connection, so the parent moved. All the other two side will move, here only the parent will move. So if you just want this to move, just is the first parent, the child will move and will have a perfect joint between the two sides. So that's about the constraints. Now we'll come back to the example and try to complete the example. So if you want, you can draw the circle and trim it, or just draw an arc. There are a lot of options. So before coming to that one, I'll try to put some dimensions. Now we don't need to use these normal traditional dimensions, because these are non-parametric dimensions which is not really editable. So I'm going to use parametric dimensions, so we don't have a lot of dimensions like this here. We have some basic dimensioning methods. Here I'm going to use the linear tool. If you want, you can select this point and this point, or else use the object method and directly select the line. So this is my first parameter, it should be 60. So when I made it 60, you see this drawing is now adjusted. It's not distorted still. Sometimes when you apply the dimensions, the drawing may be distorted, so be careful with that. Just observe what's happening when you do some editing. So remove this. These symbols are difficult for me, so I'll just hide them. Delete. I'll delete all these unnecessary lines. Now this line was also deleted. Okay. Now we will now I put the number 60. This line actually should be more than that value, given value, so I'll just drag it like this, and this should be somewhat like this. So you can get that initial shape roughly before you give the actual dimensions. That's going to be easy. So 60 given, then I'll give 35. Vertical dimension should be 35. Then this is 10 and 10, so there are two 10s, meaning that this is equal to this and this is equal to this. So I can use this equal relations now. This should be equal to this. So you see it's adjusting nicely, so I don't need to give everywhere the dimensions. So this is the object, this is 10, automatically this is adjusting. So 60, 35, 10. We'll draw the circle later, arcs later, so don't worry about the center line. If you want, you can drag it and make it big. I just made it big. Now this should be also 10 if you do a calculation, because this is 20 from here and the radius is 10, this is 10. So if you want, you can make this equal to this. Say I'll just make them equal, this one to this one. So now all the conditions are given. Now that's it. Now we'll draw the arc shape. We have these arc tools, or else you can just draw a circle and trim. That may be easy. So I'll use the circle tool, 2-point method, from here to here, circle drawn, and we can trim this now. We'll use the normal trimming methods. done. Now if I try to give a radius, so this radius, this one, okay. Now is it correct now? So I made the drawing according to dimensions. Now I try to do some changes and see whether this is working. Say 50. Now when you give 50, the problem arises now. See, I didn't give any coincident relations. So before you finalize the drawing, make sure every joint is connected using the coincident symbols. So I will apply the coincident symbol relation here. Done. So you see it's now there's a problem. So I will apply again. Okay, coincident. Now when I here also the coincident symbol is missing. Better you apply them, otherwise the drawing may get distorted. It's already existing. So we will see now change this drawing to 50. Now it's adjusted, but the radius is going here and there. Radius is the center point is moving here and there, so there's a problem with the center point. Other drawings, other parts I think quite okay. Say we say 20. Now we choose. We say here 5. Dependent expression cannot be evaluated. So this is depending someone. So we will try to rectify this problem. Now the problem here is the center point moves here and there. Center point should be collinear to this. So actually we can make this center point fix if you like. So the easiest way of doing that is we just use the fix command and try to fix this circle. Now we see what happens now. Still it's moving. I'll try to apply the condition. Says over constraints. So there's a small issue with this how to make this center movable. Other parts are okay, so you have to nicely adjust this center. Now if I just give say 20 here, we cannot give it because sorry, we'll try to give it, cannot be evaluated because there's a lock here. So I'll try to delete this. Undo, will undo. For that previous problem I found a solution. So I actually redrew this one, and now it's working. Say if I just give a value say 50, now it's nicely adjusting. So I will show you how it can be done. So from the beginning, so we have to delete the previous arc I drew, and I used a circle and did it. So we have to delete that. So I deleted it. So the problem we had was the center line moves along this line. So we have to prevent that. So it's easy to prevent. There may be other methods. So this is the method I found now. So I'm trying to draw a horizontal center line, horizontal line, and try to have the circle center in this intersection. So I will make this horizontal, and this should be collinear with these lines. So I will apply collinearity, and we can make this fix if you like. Now it cannot be taken here and there, so it cannot be moved, but the length can be changed. So these two symbols, these two lines should be center lines. So we load the layers and make it center line. Now we can use the arc tools. I'm going to use the arc tool called center start end. Center is now clearly defined. Say I'll just give the intersection center starting ending. Make sure you apply coincident symbols. Coincidence relations. Done. Done. Now when you change this value, say to 70, now the circle nicely adjusted. You see now it's not going here and there. So if I just make it 50, it's not going here and there. This line should be a center line, so this line should be a center line, then you don't see this continuity. Then if you press it to 80, should nicely adjust. So that this is the whole idea of parametric drawing. So you can quickly adjust your designs without wasting much time. So we will look at much more settings available here. Now I use this radius tool. We have the angular tool, diameter tool. So if you don't like these things, you can hide them and take them back, take everything back. For show hide, select the required things and hide that one only, or else you just hide it from these buttons. If you want to delete it, you right click and use the delete tool. So everything, hide everything. Then we will look at what is meant by this tool, convert tool, and we have this parameter manager. So convert tool is, I have a I have I have to give a linear dimension. Say I'll just give a linear dimension. This is non-parametric dimensions. Says 40. I'll take it. Reduce this size. I'll draw a small line length. Otherwise it's not visible. I'll put a linear dimension. Now this is non-parametric dimension. So if you want, you can convert this non-parametric dimension to parametric dimension from this convert tool. So we just need to select the associative dimension and press enter key. So it will automatically convert this to a parametric dimension. So if you already have drawings with non-parametric dimensions, just convert it. It's a simple thing. Now we look at what is meant by parameter manager. So if you just click on the small constraint small arrows, you will you will be driven into the settings. Normally everything is on, and there's an automatic tool also. I didn't use this, so you can ask the software to automatically constraints, but better you use these correct settings and do it. Sometimes the software will not do it for you. And you can change the transparency and dimensional also. Now we have the name here, variable name, and the dimension. If you want, you can have only the name like this, or only the variable value like this. So better, normally we have both the name and the expression. And auto constraint tools also accept equal relations. Other relations will be automatically applied, but this is not working 100%, so you have to use some manual, you have to use your brain and do it. Then we same thing here. Here they are directly going into the geometric area. Now they are moving into dimension area. Then we have this parameter manager. So the idea here is the parameters I have given is shown in the table: d1, d2, d3, and d4. d4 is this one, so here I'll just delete it. It's not here. So I have only these dimensions. So if I just try to apply a radius to this may be r1, radius 1. So these parameters are now coming. So if you want, you can double click on this and change the value, say 50. Your drawing should be automatically adjusted. Now here also I am getting the problem again, because this radius was not changed. So we have to give a relationship between the radius and the this d1. So that's the whole idea of doing this. We can give some equations between these. Now this d3, we can have only one independent variable like d1, and the others can be dependent on d1. So d1 is 80. Why I just delete this. If I just try to make it 50 again, now nicely changing. So if you give a relation, there is a problem coming out. So I will just try to give it relation and I'll sort it out. Now in the original example, these are the values. So this is 60, this is 1/6 of that 60. So initial value is 3, and this should be 10. So we can give a relationship between 60 and 10, and 60 and 35, 60 and 10 here. So this may be my independent variable, these are dependent. So how can we give a relation? So this is d1 divided by 6. So when we give this one, automatically this is changing into a function d1 divided by 6. Then this is also d1 divided by 6. So here idea is I am changing only d1, the others are all dependent. So d2 is 35 over 60, that is 35 divided by 60 is 0.5833. So this is 5833. So this is not very accurate. Now we will change this to 50. Automatically the others are now adjusting, so you can see it's changing. 70. Now this is nicely changing. So this is really handy when it comes to editing in your drawing. So d1, when I change one independent variable, all the other dependent variables are going to change. So you can do this example and see whether it's working for you, and practice more questions. So when you get an exam question, you can use this method also, no problem with that. So I hardly use these traditional modification tools. uh, so these are actually not needed when you use these parametric methods. Now you can try this example also and see. If you look at chapter 11 tutorials, try these simple examples and uh, see. So here also we can do it. Apply the coincidence symbols for all the joints, and this can be the independent, or this can be the independent, others can be dependent. So when you change 5 to 10, the others should nicely adjust according to the relations. So we did this example. So I hope you understood the concepts. So we will come up with another new lecture soon. Thank you for watching this video. Goodbye.